Okay, as we start to make our transition into trigonometry, we're going to take a look at how to measure angles in this very short lesson. And there's really two ways to measure an angle in trigonometry, and that is what we call Radian Measure, which is brand new, and we're going to discuss it very briefly. And then of course there's Degree Measure, which you were introduced to all throughout your mathematical studies everywhere, anywhere from elementary school all the way up to high school. So let's get into our new way of measuring an angle, which is called a radian. And if you take a close look at it, it almost looks like the word radius. And it's very close in that fact because that's really what it is. A radian is the measure of an angle, and this is going to be something very common in trigonometry. This is called theta, and so we're going to have a lot of Greek alphabet letters that we're going to be using to denote angles and angle measurement. So a radian is the measure of an angle theta that, when drawn as a central angle, subtends an arc whose length equals the length of the radius of the circle. Now I know that's a lot of stuff to talk about, but let's take a look at the circle here. Basically what we're talking about is that we have a central angle right here at theta, all right? And you can see that we have an initial side and a terminal side for our angle. And so our arc length is out here on the circle, okay? And then our radius, of course, is the distance from the center of our circle to the circle itself. When the arc length and the radius are the same, that's what we would say is 1 radian, okay? So therefore, the length of the arc, S, is our variable we're going to use to denote the length of an arc, is equal to our central angle measured in radians times the radius of the circle. So it makes sense that if our radius increases, this distance is going to increase. All right, now let's go back in time a little bit to our geometry days, and let's just remember that an arc length was calculated by doing what? Taking that central angle, which was in degrees, and dividing it by 360 degrees, which was 1 revolution or 1 trip around the circle. And then we multiplied it times 2 pi r, which is the circumference of the circle. So basically what we were doing is we had to figure out how big of an angle that we had at the center of our circle, and if you were to draw those pieces, that would make the wedge that you would be looking for, and the outer edge here, almost like the pizza crust of a pizza, that would be your arc length. And so since you use degrees in geometry, okay, let's make that transition then into radian measurement. So what's new here? So 1 revolution, what's a revolution? It's 1 time around the circle, okay? 1 revolution, what does that equal? Well, if you go back to your geometry days, 1 revolution is 360 degrees, and that's why your formulas back in geometry had to take whatever piece or whatever angle you had, whether it was 30 degrees or 60 degrees or 90 degrees, and then you had to divide that by 360 so that you could find out what piece of the circle that you had. But one revolution, 1 time around, is equal to 360 degrees. However, you could also say that 1 revolution is equal to 2 pi. Thus, the formula 2 pi times r would give you the circumference of a circle. So we end up with this relationship here. Since 1 revolution is the same for both 360 and 2 pi, we end up with this relationship right here. Now, if I was just to solve this for pi by dividing by 2, I would simply end up with pi is equal to 180 degrees. Now that might not seem like much, but really that is the key to converting back and forth from degrees to radians and radians to degrees. You see, if I want to figure out what 1 degree equals, then basically all I'm going to do is take this relationship and I'm simply going to divide by 180. So therefore, if I write it down here real at the bottom, 1 degree is simply going to equal what? Pi divided by 180 degrees. Okay? Or 180. However, if I take pi and divide it, and again, let's keep in mind here that this would be pi radians, and I divide it by 180, then 1 radian is equal to 180 divided by pi. And these are the two relationships that we want to use as we go forward converting back and forth. So let's do a little bit of practice. To convert from degrees to radians, we want to bring our relationship back in, that 1 degree is equal to pi over 180 radians. So to convert from degrees to radians, you simply multiply by pi over 180. So let's work some problems very quickly. 30 degrees, I want to convert it from degrees to radians, okay? So what am I going to do? I'm going to multiply times pi over 180. Now I hope you can see that basically 30 will go into 180 6 times, so this is going to be 1 over 6, so I end up with pi over 6 radians. By the way, you leave your answers in terms of pi. You don't need to multiply by 3.14. If you wanted a decimal equivalent to this, then you could take your conversion for pi of 3.1415, or however many decimal places you want to go out, and then divide it by 6. But we usually just leave it in terms of pi. How about 180 degrees? Again, I want to convert it to radians, so it's pi over 180. 180 divided by 180 is 1, so basically 180 degrees is just equal to pi radians. Okay? You might want to turn off your video for just a second and see if you can figure out these next 3 problems. So let's take a look at what 240 degrees would look like in radians. Again, we're going to multiply times pi over 180. Now, if you feel comfortable having to, or uncomfortable having to deal with these fractions, you can put a 1 underneath the 240. And then as you can see, we're going to reduce. The zeros could be reduced out. And 24 and 18 both are divisible by 6. So this is going to end up being 4. 18 is going to be 3. So we end up with 4 pi over 3 radians. Now how about negative 45 degrees? Well, just like negative degrees, which we're going to talk about a little bit later, you can have negative radians. Once again, the process doesn't change. You multiply times pi over 180. Once again, if you feel more comfortable putting the 1 under the 45 to help you reduce or simplify, there's basically 4 times 45 degrees will go into 180, so this will be 1 over 4. So we're going to end up with negative pi over 4 radians. Now you don't have to write radians after each term. Some textbooks just put a little r. Some textbooks don't put anything at all. It just depends on what you're using. The very last problem here, 540 degrees. Once again, the process does not change. We're going to multiply times pi over 180, and then we're simply going to reduce. Now 54 divided by 18 is just 3, so we end up with 3 pi radians. So to convert again from degrees to radians, what do we need to do? We simply need to multiply whatever our degree is times pi over 180. And keep in mind, notice our pi is in our numerator, so that after we multiply everything out and simplify, we end up with pi in our answer. That's very important, because when you're converting to radians, you usually are going to have pi, not always, but usually are going to have pi in your answer. Now let's go the other way. What if we want to convert from radians to degrees? So 1 radian would be equal to what? 180 over pi degrees. So to convert from degrees to radians, you simply multiply your radians by 180 over pi. So let's do a little bit of practicing here. This is simply going to be pi over 4 times 180 over pi. Okay, why did I multiply? I took my radians and multiplied it times 180 over pi. The pi's, as you can see, are going to reduce. 180 divided by 4, well, what does that work out to be? 45, correct? So this would be 45 degrees. Let's take a look at problem number 2. We're going to have pi over 2, which is our radians, and we're simply going to multiply that times 180 over pi. The pi's cancel out, or reduce out. 180 divided by 2 is 90. So pi over 2 is equal to 90 degrees. As you get better at these, you'll be able to actually do them in your head. You won't even need to do them on paper anymore. But until you get comfortable with them, you do want to work these problems out. So I'm going to simply put, again, we're converting from radians to degrees. And once again, my pi's will reduce. That's very important. If you get confused about which way to go, I see one of them is, when we're going to radians, it's pi over 180. When you're going to degrees, it's 180 over pi. That can get very confusing. So I'm trying to give you little pieces that will help you. When you're converting, there shouldn't be pi left in the question. Now, of course, in upper level mathematics, pi may still be, because you can have pi degrees. Remember, pi is just a number. It's an irrational number. So you can have pi degrees. That's possible. So just keep in mind that right now, we're just trying to keep it basic and work through the problems. Most of the time, your pi will cancel out. But there are times when it won't. Okay? We already know that 180 divided by 4 is 45. And 3 times 45 is 135 degrees. So therefore, 3 pi over 4 is 135 degrees. And last but not least, if I have a negative, again, we're going to multiply by 180 over pi. Okay. Once again, what's going to happen? My pi's will reduce. 180 divided by 6 is 30. Negative 5 times 30 is negative 150 degrees. So let's just summarize, again, a very short lesson here. Let's just bring everything back and wrap it up. Very simple little wheel here. If I'm going from degrees to radians, I'm going to multiply by pi over 180, simplify, and I'll end up with my answer. If I'm going from radians to degrees, I'm going to multiply by 180 over pi and simplify and end up with my answer. Again, remember, when we're getting to radians, pi likes to be in the answer. When we end up with degrees, can't guarantee pi will be in the answer.